So, good evening, everyone.
Yes, sir. It is audible.
Okay. So, wait. How many people are joined?
Only 11.
Only 11. Okay, just wait.
Okay, sir.
So, last week I will send the material. Okay, 2 chapters.
Sir, no, which sir?
Morning metal complex. I'll have to take printout or write the notes. So today I will send this lesson also. Okay. After complete this session, I will send this chapter PDF is there. Send that.
Sir, no.
Tell me. Okay, shall we start the class? So listen, all of you. So in the last class, we have discussed about the what is the topic? We have discussed about the reaction means the square planar complex, their reaction mechanism, the reaction mechanism of square planar complex. Okay, so that is prefer to the which platinum is the prefer that platinum is the metal that is prefer the formation of the square planar complex. And just wait, I will share that and explain. There is no focus. Just wait, just wait.
Sir, I have not received any material, sir, previous classes through which you have sent.
Group is there, no group in the. I will share the group.
A Telegram group, sir.
That is Telegram group.
Okay, sir.
I will send the group. The individual numbers are not there now.
టెలిగ్రామ్ గ్రూప్ లో కూడా ఏం రాలేదు సార్
Group
మెటీరియల్
is there, I will send the.
టెలిగ్రామ్ గ్రూప్ లో ఏం మెటీరియల్ రాలేదు సార్ లాస్ట్ క్లాస్ మీది
నేను పంపించాను 2 chapters పంపించాను. That is the Telegram group.
సార్ నోట్స్ ఏం రాలేదు సార్.
లేదు సార్ రెగ్యులర్ గా
నోట్స్ రాలేదు సార్.
M.Sc. Counselor.
టెలిగ్రామ్ గ్రూప్ లో ఏం రాలేదు సార్.
టెలిగ్రామ్ గ్రూప్ వచ్చేసి ఎంఎస్సి
Counselor,
కెమిస్ట్రీ
M.Sc. Counselor group. Students are not there in this
లేదు
group.
సార్ ఆ గ్రూప్ లో లేము సార్ మేము.
Okay,
ఓన్లీ టెలిగ్రామ్ గ్రూప్ లో అందరం ఉన్నాం
only
సార్. దాంట్లో
only
నోట్స్ అయితే
faculty is
రాలేదు.
there. That group.
ఓకే
Okay, I will send after complete the class.
సార్.
Anyone give the WhatsApp group is there?
Yes, sir.
WhatsApp.
వాట్సాప్ గ్రూప్ లో మేము లేము సార్. ఓన్లీ టెలిగ్రామ్ గ్రూప్ లోనే ఉన్నాం.
ఏంటమ్మా?
వాట్సాప్ గ్రూప్ లో మేము లేము సార్. కొంతమంది ఉండొచ్చు. టెలిగ్రామ్ గ్రూప్ లో అందరం ఉన్నాం సార్ మాక్సిమం.
Anyone send WhatsApp group? I will.
So in the WhatsApp group, I will check cross check. I will there in the WhatsApp group. I will send the material in that group. Okay.
టెలిగ్రామ్ గ్రూప్ సార్.
Already I will post 2 chapters.
Sir, official Telegram. Sir, official Telegram app use చేస్తున్నాం సార్. WhatsApp అయితే ఏ లింక్ లేదు.
వాట్సాప్ గ్రూప్ కొంతమంది మాత్రమే యూజ్
Complete the class.
చేస్తున్నారు.
I will send 3 chapters. Okay.
Okay, sir. Okay, sir. Please.
So listen. No class. Listen. So in the last class we have discussed about the square planar complex reaction mechanism. Okay.
Yes, sir.
Just wait. So the only which metal is prefer the formation of, and means some metals are prefer the formation of square planar complex, but only platinum is the suitable for that. We are explain the reaction mechanism of platinum complex only. Then that is give the some trans effect means product, trans product. Sometimes the cis product is more stable or major formation of, sometimes what trans product, that is depend on the what effective series, the ligand series or trans effective series. Based on that series, this type of complexes are formed. I will explain that last class. Okay, how this type of why this type of complex is formed, why, what is the reason. Okay, we can explain the mechanism complex, we can explain the mechanism of this which complex, square planar complex. Two theories are involved. That means based on the two theories, based on the two theories we have discussed the reaction mechanism of the square planar complex. Two theories are influenced, that means involve the two theories. Okay, one is the which theory, that is the electrostatic polarization theory. The first theory is what? Electrostatic polarization theory. And the second theory is the pi bond theory. Two theories are there. Electrostatic polarization. Electrostatic. That means what? Dipole moment of the complex. Dipole moment. Okay. The second one is the pi bond theory. Second one is the pi bond theory. Both theories are very, very important for the examination point of both theories. So here compulsory question is given the question for the examination. What is the question? Write a note on the trans effect, give the applications, very, very important, or explain the trans effect theories. These two questions are very important, long question. Okay, compulsory question. These two are compulsory question. So explain the pi bond means trans effect theories. Two theories are there. I will explain that theories. And another question is what means what is the trans effect, give the applications, give the applications of trans effect, explain and give the applications of trans effect. That is I will we are discussed about in the last class. So now what is the electrostatic polarization theory? The second one, first one, what is the electrostatic polarization theory? So here observe here. So what is the central atom? Central atom is the platinum. Central atom is the platinum. Okay, so in this central atom is up surrounded by the four ligands, surrounded the four ligands. So for example, four Cl ligands, four Cl ligands or four ammonia ligands, four Cl or four ammonia ligands. Okay, so here what is the electrostatic polarization of this? That means what is the dipole moment of this? What is the dipole moment of this? So the dipole moment mu is equal to 0 here. Mu is equal to 0. The starting product or starting material, the mu is equal to 0. Okay. So in this complex, we can substitute one incoming ligand, that is ammonia or Y, any one ligand, ammonia or Y or some other. So different types of ligands are there now. Okay. So here mu, the polarization, the dipole moment is the 0 dipole moment. So that means what? Here Cl, the strength of this Cl and the strength of the opposite Cl also similar. Okay, the bond length, bond angle of this Cl and this Cl are also similar, and the bond energy of this bond, the energy of this bond also same. Okay, same properties. This bond property and this bond property is same. The opposite bond property is same. That means what? Mu is equal to 0. There is no dipole moment. That is the left and right. For example, left hand and right hand side. Left hand side is the Cl ligand, right hand side also Cl ligand or X ligand, anyone similar ligand or homolytic ligand, homolytic, anyone, not only the Cl, any ligand, homolytic ligands, both sides are same ligand. That means what? The strength of the bond and bond angle, bond length, energy, bond energy, all are similar, all are equal. Similar in the point, all are equal. In that condition, the dipole moment is 0. The dipole moment is 0. That is what electrostatic, electro means polarization. Okay, electron polarization. What is that? Electron polarization. And the similar and top and bottom also. Top and bottom both are Cl. Both are Cl or both are X ligand. Both are X ligand. So in this orientation, mu also 0. Okay, the bond length of this, the bond of this, the bond angle of this, and the bond angle of this, the bond energy of this and the bond energy both are similar bond energies. So from the top to bottom, mu is equal to 0. Mu is equal to 0. That means there is no dipole moment. There is no dipole moment. So here what? Platinum is acting as which condition? Platinum is acting as nothing but what is the oxidation state of platinum here? What is the oxidation state of platinum? Platinum is partially positive charge. Partially positive. Ligands are nothing about the partially negative charge. L or Cl. L not L not Cl. L is nothing but ligand, any ligand, not only Cl. Okay, these are contain what? Partially negative charge. So okay, so the this partial negative this side, this partial negative this side, both are so means a similar pattern or similar bond angle, similar bond length. Okay, similar bond energy. So similar bond energy. So that means what? Here to here bond angle, bond length, bond energy are same. Here to here is same. Okay, positive negative attraction is same. Positive negative attraction is same. Okay, so the dipole moment is 0. Dipole moment is the 0. For example, the bond length, some distance are there. I will explain that. So bond length, the bond angle. Okay, there. This side also same. That is the starting material. In this platinum complex is substituted the Y ligand. That means here this condition is the 0. First condition mu is equal to what? 0. Okay. The second condition, that means substituted group. That means Y is the substituted. So here the Y is the ligand. So which is the outgoing ligand here? The 4 ligands are there. Which is the outgoing ligand? All ligands are similar way. All ligands are similar properties. Any one ligand. Not only we are not specific mention the substituted ligand. In this condition, we are not specific substitute mention. What? Hear my voice?
Sir, not clear, sir.
Not here.
Sir, can you show little bit? Yeah, voice is clear, sir. Can you show the document?
What?
Sir, fast page का photo please.
Breaking. So clear voice.
Sir, fast page का photo.
So everything is okay.
Upper page.
Photo what?
Sir, screen में आप देख रहे हैं तो.
Sir, that image is showing. That image is little bit you can zoom it, sir. Means it is. It's not appear, sir. సరిగా కనిపించట్లేదు. కొంచెం దాన్ని జూమ్ చేస్తారా?
నేను image పెట్టలేక I will explain only. Not correct image is not put in the image. Just you listen the class. After that I will explain the image.
Yes, sir. Yes, sir.
After explaining, I will show the image.
Yes, sir.
Okay.
Yes.
Okay. I am not putting the image properly. Just I will explain that. After that I will show the image. So, just wait. So this is over. In the upper page is over. So lower page I will share and explain that. First will concept based explanation is there. You will listen. So here what? Platinum is the central atom that is bind with the 4 ligands. So the incoming ligand is Y. This Y is substituted NEL. Why? Because of Here mu is equal to 0. Mu is equal to 0. That means what? Dipole moment is 0. Dipole moment is 0. In that condition, any ligand is a substituted ligand. Any ligand is a substituted ligand. So for example, the substitute of this ligand. So what happened after substitution? One first ligand substitution. What happened? That is converted into the what? Platinum. So here Y is substituted ligand. Y is the incoming ligand. L is the outgoing ligand. Then remaining 3 ligands are there. 3 ligands are there. 3 ligands are there. So in this condition, you can observe that. Okay. So the total this theory depend on in this point only. Okay. You can means listen carefully. Okay. See here Y is there. Here Y is there. Okay. In this condition, the second incoming ligand is choose or identify the labile position So which is the labile position? So for example, here L. This is L. So Y is already substituted the one of the coordination sphere. Okay. The strength of this ligand, the strength of Y is depend on the identify the what? Labile position. Identify the labile position. So in this condition, so Y is strong ligand. Y is a strong ligand. For example, Y is the incoming ligand is a strong ligand, or strong means more trans-effective ligand. So that means what? This bond, which bond? This bond is a short bond. Okay. That means the attraction between platinum and Y is very attractive is there. Okay. Decrease the bond length. Decrease the bond length. You can clearly understand that point. Okay. Platinum ki Y ki madhya unna bond length అనేది తగ్గిపోతుంది. ఎందుకు? ప్లాటినం కి Y మధ్య కాబట్టి అట్రాక్టివ్ గా అటాక్ అవుతుంది. దేనికి? ప్లాటినం కి. ఆ కండిషన్ లో ఇన్ దట్ పొజిషన్ వాట్? Platinum, the opposite ligand is there, no? So the opposite ligand of this, which ligand? This ligand. Okay. Somewhat their bond length is increase. At the same time, bond energy is decrease. Okay. That condition, the second incoming ligand. So enter into in this pattern. That which pattern? Opposite pattern. So in this condition, this is the entering ligand. Y is the entering ligand. At the same time, L is the departure ligand. In this condition, which is the more complex is formed? Trans is the more formation. So what happened here? The dipole moment is not equal to 0. The bond strength of this high, the bond strength of this low. Okay. The bond energy of this high, the bond energy of platinum L, opposite L, is the low. Okay. Bond length, this is the short bond. This is the long bond. So that means this is the departure ligand. అంటే బయటికి వెళ్ళిపోయే ligand, departure ligand. So Y is here entering ligand. So here the formation of the 5 coordinate complex. Here what? Trans is the major. That is one type of explanation. Second type of explanation. What is the second type? Same complex. Okay. So here the incoming ligand is the Y. The incoming is the what? Y is the incoming ligand. So what happened? Platinum. So here Y is attacker. Okay. 4 ligands are 4 corners. 3 ligands are remaining, 3 corners are there. So here this is the first step. Then the second incoming ligand. Second step nothing but second incoming ligand. is identify the label position. Identify the label position. That means what? Which is the weak bond? Label is nothing but which is the weak bond? Which is the weak bond? ఏ బంధం బలహీనంగా ఉంది అని చూస్తుంది సెకండ్ లైగండ్. సెకండ్ ఇన్కమ్ లిగండ్ వచ్చి అక్కడ చూస్తుంది, 4 బంధాలను చూస్తుంది. ఓకే, నేను ఏ బాండ్ ని బ్రేక్ చేయొచ్చు, ఎవరిని బయటికి పంపించచ్చు, ఓకే, ఏ లిగండ్ నేను సబ్స్టిట్యూట్ చేయొచ్చు అని చూస్తుంది. దట్ ఈస్ కాల్డ్ వాట్? దట్ ఈస్ కాల్డ్ వాట్? That is identify the label position. The Y is identify the label position. In this condition, Y is the weak ligand. Is the weak ligand. This is the weak. Okay, this is the weak. In that condition, what compare with this 3L? ఈ 3L లతో కంపేర్ చేస్తే Y is the weak ligand. Weak కాబట్టి ఏం చేస్తుంది? That is bind with less attractively or less forcefully. తక్కువ అట్రాక్టివ్ గా బైండ్ అవుతుంది. ఓకే, వై. సో ఇక్కడ ఏంటిది? ద బాండ్ లెంత్ పెద్దగా ఉంటుంది. బాండ్ ఎనర్జీ ఇస్ డిక్రీజ్. లెస్ బాండ్ ఎనర్జీ. బాండ్ లెంత్ ఇస్ హై. బాండ్ లెంత్ ఎక్కువ ఉంటుంది, బాండ్ ఎనర్జీ తక్కువ ఉంటుంది. ఓకే, ఇన్ దట్ కండిషన్ వాట్? దిస్ ఎల్, ఆపోజిట్ ఎల్ is attractively bind with the or forcefully bind with the platinum. So in this condition, mu is equal to what? Mu is not equal to 0. The dipole moment is not equal to 0. This is the long bond, this is the short bond. Okay, so the second incoming ligand is choose the position. So for example, this is enter into ఈ ligand ఇక్కడ L దగ్గర వస్తుందా? రాదు. ఎందుకు రాదు? ఆల్రెడీ స్ట్రాంగ్ ఉంది అది. This ligand is already strengthly binded. So that's why this is not a departure ligand. The opposite Y is not a departure ligand. Why? Because of that is a means strongly, forcefully bind with the platinum.
Sir,
This is
excuse me,
the
sir.
weak. ఏమో చెప్పమ్మా.
Please tell me the chapter, which chapter you are please.
ఏంటిది? What?
Chapter name, please, sir.
Chapter name is the reaction mechanism. Chapter 3. In block 3. Reaction mechanism of transition metal complexes. Okay.
Okay, sir.
So here the incoming ligand is the second incoming ligand is the choose the position. In that condition, which is the level position, the opposite this position is the level position. These two are level position. Okay, this is enter here or here, level position. Okay, level position. That means the entering ligand is enter into the dipole moment, and the dipole moment is nothing but the strength of the bond. Okay, that is can explain here. Okay, this type of explanation is explained by the polarization theory, electrostatic polarization theory. Electrostatic polarization, that means the strength of the bond. They explain the nature of the bond. Nature is nothing but what? Strong or weak. A bond is strong or weak. Strong అయితే వేరే బాండ్ దగ్గర పోతుంది, వీక్ అయితే దాన్ని సబ్స్టిట్యూట్ చేస్తుంది. Okay, so this is, then I will put another show the image. Just wait. So here, observe here. Okay, so this is the platinum is the central atom. Here you can observe it. Platinum is the central atom. Okay, that central atom is surrounded by the two different types of ligands. That means after first step, okay, here this is the chlorine, this is what? Ethylene group, C2H4. Okay, this is what? Ethylene group, C2H4. Okay, so in this ligands, the ethylene is the strong ligand. Remaining 3 ligands. So in that condition, you can observe the bond length of that. Okay, so here chlorine, the above the chlorine and below the chlorine, 2 chlorines are there now. This chlorine and this chlorine, what is the bond length? 2.32 angstrom. Okay, this is the 3.32 angstrom. Below the Cl also 2.32 angstrom. And the right hand side, okay, the right hand side left hand side is ethylene group is there. This is the strong, more trans-effective ligand. This is the more trans-effective ligand. So that means in that ligand is the forcefully or attractively bind with the central atom, means platinum. In that condition, this bond length is the weak or somewhat change their bond length. That means what? That is a less attractive bond. That is a less attractive bond. So in that condition, what? This is the departure ligand. So for example, the second C2H4 ligand, okay, ethylene is the second incoming ligand. That is attack with which position? A position attack అవుతుంది అది. which is the means less attractively, less forcefully binded the ligand, or which is the weak bond. Okay, this is the weak bond. So this ligand is enter into this position. Okay, this is a departure ligand. So here the formation of 5 coordinate complex is formed. Okay, next second example. This is also same. Okay, 3 BRs are there. 3 BRs, this is a ethylene group is there. 3 BRs. So what is the bond length? The 2.42 angstrom. This is also 2.42 angstrom. This is a 2.50 angstrom. This bond is a 2.50 angstrom. Somewhat weak bond. This bond is the what? 2.4 angstrom. This bond is 2.42 angstrom. Okay, this is the platinum. Here ethylene group is there. This is a short bond. Strong bond, strength bond. Okay, the bond length is the means less. The bond length is the less, more attractively bind with the platinum. So in that condition, this is the departure ligand. Okay, this is the type of explanation can explain by the which theory? Electrostatic polarization theory. That is depend on the dipole moment of the complex. The dipole moment is given for the strength of the bond. That dipole moment is explain what? Strength of the bond. Which is the less strength? Which bond is the weak bond? That is the outgoing bond. That bond is the break. Is a very important thing. Is pi bond. That is the pi bond theory. The pi bond theory also explains the same type of pattern. Okay, we explain that. Just wait. Pi bond theory. So what is the defects? Some ligands are acting as a pi acceptor ligands. That means ligand is, what is the nature of ligand? That is donate a pair of electron. What is the nature of ligand? This is the ligand. This ligand are contain electron pair. This electron pair is donate the central atom. That is the platinum. So here platinum is a D8 configuration. That means what? In that d orbitals are filled with the electrons. Platinum
Sir,
d orbitals
can't
are
hear,
filled
sir.
with the, not clear.
No, sir. Disturbance is there.
So here so clear is there, means here there is no problem. Net is there. At the same time, full data is there. Okay. Now clear what?
No, sir.
Not clear. Now clear? Hello?
Yes, sir.
Clear, sir.
Okay. Now listen. Now clear voice?
Yes, sir. voice is there.
Okay, so here the central atom is the platinum. So the ligand is contain the electron pair, that is donated the electron pair. So at the same time, some ligands are contain the vacate orbitals. Some ligands are contain the vacate orbitals. Okay, the platinum, the central atom is the platinum. Here, platinum is the central atom. That is contain 8 electrons in the d orbital. That means platinum d orbitals are contain the electrons. Platinum d orbitals are contain the electron pairs. Okay, so here ligand is donated the electron pair the central atom. That is the formation of the sigma bond. That means this ligand is acting as a sigma donor. Acting as a what? Sigma donor. At the same time, ligand are contain vacate orbitals. They are p or d orbital. P or d orbital. Sometimes some ligands are contain vacate p orbitals, or some ligands are contain vacate d orbitals. Okay, metal is always contain the field d orbitals. So what is the point? The almost fulfill of d orbital metals is the formation of prefer to the formation of the square planar complex. That means the d orbitals are contain always electron, fulfill electron. That means d8 d9 configuration. They are which type of metals are formation of square planar complex? The metals are contain d orbital d8 configuration or d9 configuration metals. So platinum is the d8 configuration. That means what? This is a metal is always contain the d orbital. Metal is always contain the d orbital. So this fulfill of d orbital is donate the electron to the ligand. Okay, this is what pi bond. Pi bond. What is the name of that pi bond? Is a pi acceptor. Pi acceptor. Okay, here what? Ligand is donate the electron pair to the central atom. At the same time, ligand is also accept the electron pair from the metal. Always means act the electron, accept the electron pair from the metal. So this bond is the pi bond. This bond is the pi bond. That is the pi acceptor. Pi acceptor. So this type of explanation is not explain the electrostatic polarization theory. This type of explanation is not explain the electrostatic polarization theory. So this theory was proposed by the Sidgwick is a scientist. Okay, who was the proposed this theory? The Sidgwick is the scientist. The pi bond theory is proposed by the Sidgwick is the scientist. Here what? Same simple thing. Ligand, those ligands are contain vacate d orbitals. That is accept the electron pair from the metal. That is accept the electron pair from the metal. The type of bond is the pi bond. The type of bond is the pi bond. Okay, that is the name of the bond is the pi acceptor. The name, what is the name of bond is the pi acceptor. Okay, sigma donor. Ligand is always sigma donor. Ligand is always sigma donor. Some ligands pi acceptor. So this type of explanation is not explain the electrostatic polarization theory. So some defects is there in that theory. What? Some defects are there. So rule out that defect, the type of defects, and this is the advanced theory. This is the advanced theory. So the here another point is there, important point. So here metal is always contain the d orbital. Metal is always contain the d orbital. Okay, ligand is sometimes contain vacate p orbital. This type of bond is known as the d pi p pi bond. D pi p pi bond. What is the name of this bond? D pi p pi bond. That means ligand is contain the vacate d orbital. Ligand is contain the vacate d orbital. The name of bond is the d pi p pi bond. Sometimes metal is contain the d electron. Ligand also contain the vacate d orbital. Okay, this type of bond is the d pi bond. This type of bond is the d pi bond. Okay, so two types of pi bonds are formed in between the metal and ligand. In between the metal and ligand. So here, what is the point? Metal is donate electron pair to the ligand. To the ligand. So which type of ligand they accept the electron pair? Those ligands are contain those ligands are contain vacant orbitals. Those ligands are contain vacant orbitals. Okay, so this type of explanation can explain by the pi bond theory. Can explain by the pi bond theory. So now you show the image. Image is there. I will explain that image. Means show the image. Here, so for example, here two types of bond is possible. Two types of bond is possible. They are what? P pi d pi bond and d pi d pi bond. Okay, so it is a p pi d pi bond or d pi bond also possible. D pi bond also possible. Now you can observe here. The image is there. So very important. This very important. This theory. Both theory are important. So here, this is what platinum. The black shaded is there now. That is a field electron. Platinum or contain field d orbital electrons. Field d orbital electron. That is a black shaded orbital is there. Orbit is there now. And the ligand is the unshaded orbital is there. Ligand is contain what? Unshaded orbital. Okay, that means what? That is the vacant orbital. Vacant orbital. Okay, so here you observe clearly one bond is there in between the ligand and platinum. In between the L and platinum, one bond is there. That bond is the sigma bond. This bond is the sigma bond. Okay, that means what? Ligand is donate platinum. This is the ligand. So here this bond, you observe this bond. This is the sigma bond. This is the sigma bond. Ligand is donate a pair of electron to the central atom. What is the name of bond? Coordination covalent bond. What is the name of bond? Coordination covalent bond. So here ligand is contain vacant orbital. Vacant orbital. The unshaded orbital. Okay. Next, platinum is contain the field d orbital. That is a shaded orbital. Shaded orbital. Okay. Field d orbitals. Okay, field d orbitals. So here what happened? Bond is formed. That means this is donate electron pair. This field d orbital is donate electron pair to the vacant orbital of the ligand. Vacant orbital of the ligand. Okay, so here what? In between the ligand and the platinum, two bonds are formed. Two bonds are formed. What is the bond? One is the sigma bond, one is the pi bond. One is the sigma bond, one is the pi bond. That means, what is the meaning of that? Two bonds are there. You can compare remaining all other bonds. This is a strengthened bond. That is a strong bond. Why? Because of in between the platinum and ligand, one is the sigma bond, one is the pi bond. One is the sigma bond, one is the pi bond. Sigma bond is meaning what? That is the electron acceptor from the ligand. Metal is electron acceptor from the ligand. That is the sigma bond. Second bond, that is the pi bond. What is the meaning of pi bond? The ligand is accept the electron from the metal. Ligand is accept the electron from the ligand. So in that condition, the in this case, the incoming ligand is attacked with which position? So incoming ligand is identify the label position first. The incoming ligand is the, so this is the entering ligand. Observe here, entering ligand. Okay, so that is enter into the opposite direction, which is a strong bond. Which is a strong bond, or which is the pi acceptor ligand. Which is the pi acceptor ligand? That bond is a strong bond. That bond is a strong bond. In that condition, the incoming ligand is approach the opposite position. Approach the opposite position. So you observe here clearly. Okay, it's opposite position. That is what this is the opposite position is the departure position. This is a departure position. Outgoing ligand is a departure, and enter into the incoming ligand. Enter into the incoming ligand. In that condition, what one geometry is formed. What is the geometry? The square planar is converted into the trigonal bipyramidal. In both is nothing. In the electrostatic polarization theory also, the intermediate is the trigonal bipyramidal. Pi bond also, pi bond theory also can explain the what is intermediate? Trigonal bipyramidal. Trigonal bipyramidal. Okay, so here D is nothing but the departure ligand. E is nothing about the entering ligand. E is nothing about the entering ligand. The outgoing ligand is the D, entering ligand is the E. That is anyone. Okay, here what happened? So those ligand are acting as a pi acceptor. That bond is a strengthened bond. That bond is a strong bond. That bond is a strong bond. So the entering ligand is enter into the opposite position.
Sir,
Ah,
entering ligand will always enter from the opposite direction.
yes, those ligand are acting as a, which ligand is acting as a pi acceptor. That is the entering ligand always enter into the opposite position only. So here 4 ligands ఉన్నాయి కదమ్మా, అందులో L అనేది ఏంటిది, sigma acceptor, so pi acceptor. L is a pi acceptor. Remaining 3 ligands are there, no, that is not acceptor. ఇప్పుడు ఇక 3 X'లు ఉన్నాయి, ఇక్కడ L ఉంది, పైన that is not contain vacate orbital in the bottom, and means below, above the position, below the position is there, no, this below X also not contain the electron, means the vacate orbital. Okay, this is the L. Then so this L is 2 L's are there. This L is the contain the vacate orbital. This L is contain the vacate orbital. So the incoming ligand is always opposite position. Always opposite position. Always the formation of the trans position. Always the formation of the what? Trans position. So the means this theory is explained perfectly. This theory is suitable for the explanation is a square planar complex. Suitable for the square planar complex. So this is a electron means the pi bond theory. This is a very very important theory. So based on this we can explain the mechanism. What is the mechanism here? What is the pathway mechanism? Which pathway is possible here? I will explain. I already will tell that in the polarization theory and pi bond theory, in both theory is the intermediate is the formation of what? Trigonal bipyramidal geometry. So you can explain that which is the pathway, which pathway is suitable for this. SN1 pathway suitable or SN2 pathway suitable? SN2 is the suitable pathway. SN2 is the suitable pathway. Why? Because of here association is takes place. No, the 4 coordinate complex is converted into 5 coordinate complex. What is the geometry? Trigonal bipyramidal geometry. Okay, 4 coordinate is nothing but what? Square planar complex. Okay, after that is converted intermediate, that is a short lived. Intermediate is a short lived, their lifetime is very short. That is again immediately converted into the product. So the 4 coordinate complex is converted into the 5 coordinate complex, again converted into the 4 coordinate complex, again converted into the 4 coordinate complex. What is the pathway? This association pathway. Association nothing but which? SN2 mechanism. SN2 pathway. So this is the mechanism of the square planar complex reaction mechanisms. SN2 pathway is the possible. SN2 pathway is the possible. So in the geometry, they change their geometrical entity in the intermediate. So 5 coordinate complex. Sometimes in the 5 coordinate complex, 2 types of geometries are possible. 2 types of geometries are possible. That means in the 5 coordination, intermediate is a 5. So starting material the 4 coordinate, that is also always square planar. Product also always square planar. In the intermediate 5 coordinate. Okay, 2 types of geometries are possible in the 5 coordination. One is the trigonal bipyramidal geometry. The second one is the square, sometimes square pyramidal also possible. Sometimes square pyramidal also possible. Okay, so here explain that. So which means in the which condition that is give the trigonal bipyramidal, and which condition that is give the square pyramidal, which condition that is give the square pyramidal. Okay, so here and why that is prefer the SN2 pathway, that is also explained. Okay, why that is means give the preferable SN2 pathway. In general, in the octahedral complex, you compare the both. In the octahedral complex, SN1 is the preferable pathway. SN1 is the preferable pathway. SN2 is not a preferable pathway. Why? Because of in the SN2 pathway nothing but association is takes place. Association is takes place. That means the 6 coordination is converted into 7. That is somewhat difficult. So somewhat difficult. That means what? That is the unstable. Unstable. At the same time, that is occur the steric hindrance. Steric repulsions are takes place. This is somewhat difficult. In the SN1 pathway, for the explain octahedral, in the last class I will explain that. SN1, 6 is converted into the 5. Very easily convert that. 6 is 5, very easily convert. There is no steric repulsions, there is no steric hindrance. Elant repulsions ఉండవు కాబట్టి SN1 is preferable for the octahedral. Okay. In this square planar, SN1 is not preferable. SN2 is the preferable. SN2 is the preferable. So why that is the preferable? That so simple thing. Here what happened? So in the square planar complex, what is the geometry? What is the geometry? So the geometry nothing but platinum is the D8 configuration. D8 configuration. Okay. So here what d orbitals are there, 5 suborbitals are there, 1 s orbital is there, and 3 p orbitals are there. So in the d orbitals are contain how many electrons? 8 electrons. How many electrons? 8 electrons. Okay. 8 electrons are contained. Okay. S orbital is empty. P orbital also empty. P orbital also empty. So here what? 8 electrons are there. So here d orbitals are, we are means divided into two types. Two types of d orbitals are there. One is the two set type is not where two sets are there. One is the T2G set. The second one is the EG set. In the EG set, orbitals are involving the bond formation. EG set of orbital are involving the bond formation. They are which orbital? Dx square minus y square and dz square orbital. The d orbitals are contain what? Dx square minus y square and dz square orbital. Okay. So here 8 electrons are there. D orbitals are contain what? 8 electrons are there. Okay. In the square planar complex is preferable for the strong ligand. Always strong ligand is preferred for the formation of square planar complex. So what's happened? 8 electrons are there, strong ligand. 8 electrons are there, strong ligand. That means what? Electrons are pairing takes place. Electrons are pairing takes place. So the dxy orbitals are contain 2 electrons, xz orbital are contain 2 electrons, yz orbital are contain 2 electrons, remaining 2 electrons. Sometimes these 2 electrons are enter into this orbital, dx square minus y square orbital. So in that condition, dz square is the vacant orbital. Dz square is the vacant orbital. That vacant orbital is involving the hybridization. Okay, 1 d orbital, 1 s orbital, and 2 p orbitals. What is the hybridization? D what is dsp2? Okay, dsp2 hybridization. Okay, so here the entering the sp, so here one orbital is there, one vacant orbital is there. That is what? pz orbital is the vacant orbital. Pz orbital is the vacant orbital. So in this condition, why this is the prefer the SN2 pathway? So the incoming ligand is there. The incoming ligand is enter into in this coordination sphere. Why is enter? What is that? In this ligand enter into in this, already here vacant orbital is there, vacant p orbital is there. That is means the z orbital is accommodate for the incoming ligand. Okay, bond is not break, not dissociation takes place. One vacant orbital is there now. హైబ్రిడేషన్ లో ఓన్లీ 4 ఆర్బిటల్స్ ఇన్వాల్వ్ అయినాయి. ఏంటి అవి? ఒక డి ఆర్బిటల్, ఒక ఎస్ ఆర్బిటల్, 2 పి ఆర్బిటల్స్ ఇన్వాల్వ్ అయినాయి. 1 p orbital is a vacate. That is which orbital? pz orbital. pz orbital is a vacate orbital. కాబట్టి అది వేకెట్ ఉంది కాబట్టి ఇన్కమింగ్ లిగెండ్ అక్కడ అకామిడేషన్ కావచ్చు. అక్కడ వచ్చి అకామిడేషన్ అయ్యింది. కాబట్టి ఏమైంది? 4 కోఆర్డినేషన్ కాస్త 5 అయింది. 4 is converted into the 5. Association takes place. Association takes place. Okay. Then that is again converted into the 4. So that means SN2 is the preferable pathway. SN2 is the preferable pathway. This is the point. This is the reason. What is the reason of that? Already in that metal is contained the vacant pz orbital. That metal is contained the vacant pz orbital. So that pz orbital is accommodated for the incoming ligand. The pz orbital is accommodated for the incoming ligand. So the bond means the bond formation, bond making is takes place. Bond making is takes place. That means bond association is takes place. Bond association is takes place. So that is the 4 coordinate is the intermediate is converted in the 5 coordinate. Again, that is converted in the 4 coordinate. This is the pathway. Okay. Second point. What is the second point? In the 5 coordination, 2 types of geometry are there now. 2 types of geometry. Explain that. Listen that. So here, what is hybridization? DsP2 hybridization. What is hybridization? DsP2 hybridization. So this d orbital, 2 d orbitals are there now. So the probability 2 is there. That is the EG set of orbital is involved the hybridization. EG set are contained 2 orbitals. EG లో ఎన్ని ఎలక్ట్రాన్స్ ఉన్నాయి? 2 ఎలక్ట్రాన్స్ ఉన్నాయి. ఒకటేమో dx square minus y square, ఇంకొకటి dz square ఉంది. So here the dz square orbital are involved the hybridization. The point, direct point, the dz square orbital are involved. Only one d orbital is there, no? This d orbital is a dz square orbital. That is the trigonal bipyramidal geometry is formed. In the intermediate is which geometry is formed? Trigonal bipyramidal geometry is formed. For example, in this d orbital is dx square minus y square orbital. Okay, this is also involved the hybridization. Dx square minus y square orbital. In that condition, that is the formation of square pyramidal geometry. Which geometry? Square pyramidal geometry. Okay, this is the reaction mechanism for the square planar complex. Square planar complex. What is the pathway? SN2 pathway. SN2 pathway. This is the explanation of that. Okay, so that points also is there. I will show that points. You can observe here. సో అని చెప్పిన అన్ని ఇక్కడ దీంట్లో మ్యాటర్ అంతా ఇక్కడ ఉంటుంది. ఒకసారి ఐ విల్ సెండ్ ద మెటీరియల్ ఆఫ్టర్ కంప్లీట్ ద క్లాస్. యూ కెన్ రీడ్ అగైన్. ఆ మ్యాటర్ అంతా ఇక్కడ ఉంటుంది. వై దట్ ఈస్ ఇన్వాల్వ్ 5 కోఆర్డినేట్. ఓకే, వాట్ ఈస్ ద జామెట్రీ? ట్రైగోనల్ బైపిరమిడల్ ఆర్ స్క్వేర్ పిరమిడల్. ఓకే, 5 కోఆర్డినేట్ కాంప్లెక్స్. ఓకే, డిఫరెంట్ 2 types of geometry are possible. Square planar, square 5 coordinate, trigonal bipyramidal and square pyramidal. The trigonal bipyramidal is the dz square orbital is involved the hybridization. That is a TBP. dx square minus y square involved the hybridization. That is the square pyramidal. That is the square pyramidal. So this is nothing about the substitution reaction for the square planar complex. Substitution reaction for the square planar complex. Okay. So here.
Sir, చిన్న డౌట్ సార్ అది. హలో సార్, dz స్క్వేర్ పార్టిసిపేట్ చేస్తే ట్రైగోనల్ బైపిరమిడల్ అంటారు కదా సార్? హలో సార్, వినిపిస్తుంది? అదే సార్, అదే dz స్క్వేర్ పార్టిసిపేట్ చేస్తే ట్రైగోనల్ బైపిరమిడల్ జామెట్రీ అంటున్నారు. dx స్క్వేర్ y స్క్వేర్ పార్టిసిపేట్ చేస్తే స్క్వేర్ పిరమిడల్ జామెట్రీ అంటున్నారు సార్. సో ఎనీ రీజన్ ఏముంది సార్? కొంచెం బలమైన రీజన్.
దట్ ఇస్ ద స్టెబిలిటీ.
దేనికోసం అర్థం కాదు.
Stability. Those orbital is the two conditions are there. So one condition, one type of geometry is possible. Second condition of geometry is possible.
Reason is that sir, dz square participates
depend on the stability of intermediate. So both intermediate also stable. That's why we can explain their mechanism. For example, nickel, that is the 10 to the power of 3 times faster their substitution reaction. That means in that condition, which is the which geometry is possible, we cannot explain that in that condition. Okay, we can explain the platinum is the slow motion, that is involve the substitution reaction very slowly. So that means we can clearly explain the mechanism. So one d orbital is involved the hybridization. In that d orbital is dz square orbital, the preferable geometry is the trigonal bipyramidal. That means in the trigonal bipyramidal stable geometry. For example, involve the dx square minus y square orbital. Square pyramidal is stable geometry. Okay, that is stability, depend on stability. After that, that is converted into the product. This geometry, this stability is not fulfill this reaction. So just this orbital involve. This is the geometry. This is involved. This is the geometry. After that, that five coordinate again convert into the what? 4 coordinate. That is the mechanism. The ascent pathway is the preferable pathway for that. So here we can discuss about what, which, how many mechanisms in the means transition metal complex. We discuss about the reaction mechanism of transition metal complex. In the transition metal complex or undergoes to the nucleophilic substitution reaction. Undergoes to the nucleophilic substitution reactions at the same time coordination number of that complex. For example, octahedral, SN1 possible, SN2 possible, SN1CB possible. At the same time, another mechanism also is there without breaking metal ligand bond, without making or without breaking, without breaking metal ligand bond. That type of reaction also possible. That is also explained in the last class. So here we can discuss about the square planar complex. Okay, square planar complex. SN2 pathway is the preferable pathway. SN2 is the preferable pathway. Why? Because of I will explain already. Okay, so here we can discuss about this type of reaction mechanisms. This type of reaction mechanism. These all are very important for the examination point of view. Very important for the examination point of view. So in this chapter, some other topic is there. That is the electron transfer reaction. Electron transfer reaction. That is also explained. Just wait. I will share one image. After that, I will explain that. So the electron transfer reaction. Electron transfer from one complex to another complex. Electron transfer from one complex to another complex. The type of reaction is known as what? Electron transfer reaction. In the previously what? Transfer the ligand. Substitute the ligand, not transfer. Substitute the ligand. One of the ligand is substituted by another ligand. That is called what? Substitution reaction. That is called what? Substitution reaction. So here in this topic what? Electron transfer reaction. For example, this is the metal ligand complex plus another metal ligand complex. This is the M, this is the M prime. M prime metal ligand complex. So electron transfer from this complex to this complex. Electron transfer takes place. Or sometimes metal ligand complex plus metal prime ligand complex. Electron transfer from this complex to this complex. Okay, this is known as the electron transfer reaction. This is known as the electron transfer reaction. Okay, the electron transfer reaction is also undergoes to the two pathways. Two types of mechanisms are involved in the electron transfer reaction. Two types of mechanisms. So one is the inner sphere mechanism. Very important. This is also inner sphere mechanism. The second one is the outer sphere mechanism. Electron transfer takes place from inner sphere mechanism, or the electron transfer takes place for the outer sphere mechanism. Outer sphere mechanism. Okay, we can explain both mechanisms. So what is the main point here? Electron transfer from one complex to electron transfer from one complex to another complex. Okay, electron transfer takes place. Okay. So this type of electron transfer, two types of pathways are there. Two types of pathways are there. One is the inner sphere mechanism. One is the inner sphere mechanism. So what is the inner sphere mechanism? So this is a metal ligand complex. This is the metal prime ligand complex. Electron transfer takes place. The electron transfer takes place from one complex to another complex. Here one ligand is acting as a bridged ligand. One ligand is acting as a bridged ligand, then transfer the electron. Okay, for example, here to here electron transfer takes place. So first electron transfer from this complex to this ligand, then this ligand to this complex. This type of mechanism is the inner sphere mechanism. Only one point is this is the intermediate. One ligand is acting as a intermediate ligand, the bridge ligand, not intermediate, bridged ligand. The electron transfer from the electron transfer through the bridge ligand. Electron transfer takes place through the bridged ligand. Bridged ligand. So in this complex, loss of electron. In this complex, loss of electron. That is undergoes the reduction. That is undergoes the reduction. Okay. In this complex is the
Oxidation,
gaining of
sir.
electron. Sorry, this is oxidation. Sorry, this is the oxidation. So those complex are loss of electron, that is undergoes the oxidation, not reduction. Oxidation. This undergoes the oxidation. Increase the oxidation number. That is undergoes the oxidation. So decrease the oxidation number. So increase, not decrease. Increase the oxidation number. That is loss of electron. Increase the oxidation number. That is undergoes the oxidation. Decrease the oxidation number. Okay, the gaining electron, decrease their oxidation number, that is undergoes the reduction. That is undergoes the reduction. So here electron transfer through one of the ligand. One of the ligand, that is the bridged ligand. One of the ligand is acting as a bridged ligand. Okay, that is called what? This type of mechanism is known as inner sphere mechanism. Known as the inner sphere mechanism. Okay, outer sphere mechanism. Direct transfer takes place. Direct transfer takes place from one complex to another complex. That is called what? Outer sphere mechanism. So here there is no bridged ligand is formed. Here there is no bridged ligand is formed. Okay, we can explain the mechanism of inner sphere and outer sphere. Okay, so in the inner sphere mechanism, so electron transfer through bridged manner, through bridged ligand. So inner sphere, outer sphere. So inner sphere mechanism, 4 steps are there. The inner sphere mechanism involve the 4 steps. Sorry, in the inner sphere 3 steps are there. Outer sphere 4 steps are there. So in the inner sphere mechanism, 3-step mechanism. So what is the step? One by one I will explain that. Listen. So 3 steps. Step 1, that is the preparation of precursor complex. Preparation of precursor complex. That means that is the initiation step antam. Initiation. That means precursor complex. The command of both complex. Command of one is the oxidizing complex, one is the reducing complex. Okay. Those metal complex is the last of the electron, that is the oxidizing complex. Those metal complex, the gaining the electron, that is the reducing complex. Both are connected through one ligand. Both are connected through one ligand. That is what? X ligand. That is what? X ligand. Okay. So yeah, this is the oxidizing complex. Oxidizing complex are contain X ligand. Reducing complex are contain H2O ligand. Okay, H2O ligand. Okay, so this H2O is the outgoing ligand. Then the complex, the formation of the precursor complex. The formation of the precursor complex. The oxidizing complex and reducing complex is connect with one ligand through one ligand. That ligand is the oxidizing ligand or complex or contain X ligand. That X is acting as a bridged ligand. The X is acting as a bridged ligand. That is what step 1. What is the name of the step? Preparation of precursor complex. Preparation of precursor complex. Then second step, electron transfer takes place. Electron transfer. Okay, here what? So the oxidizing complex is the loss of electron. Loss of electron. The reducing is the gaining of electron. Reducing is the gaining of electron. Okay, so in that which is the so reducing is the reducing complex. Reducing agent is the loss of electron. Oxidizing agent is the gaining of electron. Okay, those reducing complex are the loss of electron, increase their oxidation state, increase their oxidation state. That is indicate what? Plus. That is indicate what? Plus. Those complex is the gaining of electron. Those complex are gaining of electron. Decrease the oxidation state. Decrease the oxidation state. That is the indicate what? Negative. Okay, here two charges are there. That is not charge. That is indicate. What is indicate? Plus is nothing but loss of electron. Minus is nothing but gaining of electron. Plus is nothing but loss of electron. Increase that complex oxidation number. Minus is nothing but gaining of electron. Decrease the oxidation number of that complex. Decrease the oxidation number of that complex. Okay, that is called what? Electron transfer takes place. That electron transfer through the X ligand, through the one of the ligand. That is what? X. So this type of mechanism is possible for the inner sphere mechanism. Then separation of two complex. The separation of two complex. So third step. Step 3 what? Separation of two complex. So oxidizing complex and reducing complex both are separate. Oxidizing complex, reducing complex. Both complex are separation takes place. Okay. So in that mechanism is there one, take one example. I will explain that example. So what is the example here? You can observe this example. Okay, you can observe in the bottom is there. So what is the complex? Pentamine chlorocobalt complex. Pentamine chlorocobalt complex. And the second complex is what? Hexa aqua chromium complex. Hexa aqua chromium complex. So here you can observe that in the pentamine chlorocobalt complex, the oxidation state of cobalt is the +2. The oxidation state of cobalt is the +2. Here, hexa aqua chromium complex. The oxidation state of that +2. That is also chromium is the +2. Cobalt also +2. Okay. So in the cobalt +2 condition, cobalt.
Sir, cobalt +1, sir. Sir.
No, not
oxidation
+1.
state +1 also, sir. First one. Sir, and chlorine -1 ga, sir. -1 at
already what is the
chlorine
complex?
-1 charge ga, sir.
You have pentamine chlorocobalt complex. That is the oxidation number is 3. In the out of the coordination sphere, 2 Cls are there. Out of the coordination sphere, 2 Cls are there. So that means here the oxidation of cobalt is the +2 state. Okay.
Sir, అర్థం కాలేదు చెప్పండి.
I will write down the complete complex name. Okay. Cobalt central atom. That is pentamine chlorocobalt. Out of the coordination sphere, 2 ligands are there. In this complex, we are prepared in the lab. In the practical prepared something complex. So in the out of the
coordination sphere లోపల ఉంది సార్ అక్కడ. సార్ లోపల అనేది కోఆర్డినేషన్ స్పేర్ లోపల ఉంది, బయట ఏం లేదు సార్. అవును సార్, లోపల బయట ఏం లేదు సార్. అది బ్రాకెట్ అవతల ఉంటే బయట ఉన్నట్టు, బ్రాకెట్ లోపల లోపల ఉంది సార్. అది క్లోరిన్ అనేది బయట కాదు కదా,
బయట ఉంటుంది. అది తీసేసి మనం ఇక్కడ +2 రాస్తాం. we have mentioned here +2 మెన్షన్ చేస్తున్నాం కదా. you observe here, then we can mention the +2 because of ఎందుకు మెన్షన్ చేస్తున్నాం. here 2 Cl2 are there in the out of the coordination sphere. This is not fulfill the complex. the fulfill కాదు కాంప్లెక్స్. కోఆర్డినేషన్ బయట Cl2 ఉంటది. ఆ Cl2 కూడా ఇక్కడ రాయట్లేదు. ఇక్కడ మనం Cl2 రాయలే కాబట్టి ఇక్కడ +2 స్టేట్ లో ఉంది కోబాల్ట్. ఓకే. సో దట్ ఈస్ ద కాంప్లెక్స్. అర్థమైంది కదా బాబు? యు అండర్స్టాండ్ దట్?
సార్ ఓకే సార్.
The out of the coordination sphere, Cl2 is there. Cl2 is there. For example, కాంప్లెక్స్ రాస్తాను చూడు. ఇప్పుడు టెట్రామైన్ కాపర్ సల్ఫేట్ రాసిన, టెట్రామైన్ కాపర్ సల్ఫేట్, కాపర్ టెట్రామైన్. Okay, in the out of the coordination sphere, sulfate is there. So here we are not mention the oxidation number. You can write the sulfate. You can mention the oxidation number. Tetramine copper sulfate. You can mention the oxidation number. You don't write the sulfate. అర్థమైందా? ఇక్కడ నువ్వు సల్ఫేట్ రాస్తే ఆక్సిజన్ స్టేట్ రాయాల్సిన అవసరం లేదు. నువ్వు ఆక్సిజన్ స్టేట్ రాస్తే సల్ఫేట్ రాయాల్సిన అవసరం లేదు. దిస్ ఇస్ ద కాంప్లెక్స్ టెట్రామైన్ కాపర్ సల్ఫేట్. ఇది కూడా రాయొచ్చు, కరెక్టే. ఇది కూడా రాయొచ్చు, కరెక్టే. In the out of the coordination sphere, negative charge species are there. You can remove that species. You can mention the oxidation number. You can write that. You cannot mention the oxidation number. Okay. So here in this complex
+3 oxidation state, na sir?
So plus
Hello, sir. Sir, overall cobalt oxidation state is
overall is the +3. Overall is the +3.
Yes sir. In that complex ionic form,
oxidation state.
Yes sir.
Overall is the +3. Okay. So in that complex, so you can observe the reaction that electron transfer reaction. The pentamine chlorocobalt complex is react with the hexa-aqua chromium complex. So here cobalt is the loss of electron, chromium is the gaining of electron. Chromium is the gaining of electron. At the same time, ligand transfer also takes place. ఇక్కడ chlorine ఉంది, pentamine లో chlorine ఉంది. Here chlorine is there. Here aqua, 6 aqua is there. After transfer the electron, chlorine place లో aqua వచ్చింది, aqua place లో chlorine పోయింది. At the same time, electron transfer తో పాటు ligand transfer కూడా అవుతుంది. Takes place the ligand transfer also. Okay. So that is the reaction. You can observe the reaction mechanism of that. You can observe the reaction mechanism. So here chromium step 1 చూడండి ఇక్కడ pentamine chlorocobalt hexa-aqua complex. So here chromium is the +3 condition లో ఉంది. So cobalt is the +3 condition, overall +3. Chromium is the +2 condition లో ఉంది. So here Cl is the bridge ligand. What is the Cl is the bridge ligand and the loss of one water molecule. Loss of one water molecule. Okay. So in that complex, in that cobalt is the +3 oxidation state, chromium is the +2 oxidation state. So here electron transfer from chromium to cobalt. Electron transfer from chromium to cobalt through one of the ligand, through one of the bridge ligand. What is that ligand? Cl is the bridge ligand. So here electron transfer takes place. So after transfer the electron, what happened? After transfer the electron, what happened? So those metal is the gaining of electron, decrease their oxidation number. That is the +2 convert aitundi. Okay. Cobalt is the convert to the +2 state. +3 నుంచి +2 కి వస్తుంది. Chromium is the convert into the +3. Chromium +2 నుంచి +3 కి వచ్చింది. So in that condition, you can mention the d electron also. Cobalt +2 condition, cobalt +3 condition. D orbitals are contain 6 electrons. Chromium +2 condition, that is contain the 4 electrons. After transfer the electron, cobalt is converted into the +2 state. In that condition, how many electrons are there in the d orbital? 7 electrons are there. Okay, you observe here. So cobalt +3 state lo undi, chromium +2 state lo undi before transfer the electron. So this is the d6, this is the d4 condition lo undi. So after transfer the electron through Cl ligand, after transfer the electron, cobalt is converted into the +2, chromium is converted into the +3. After transfer the electron, okay, electron ekkadi nunchi ekkada vachindi? This is the +3. Electron ekkadi nunchi? Chromium nunchi cobalt vachindi. Cobalt is the contains 7 electrons. 6 7 అయింది. chromium 4 కాస్త 3 అయింది. Okay, electron transfer takes place from chromium to cobalt through one of the ligand. What is that ligand? Chlorine is the ligand. So after transfer the electron, those metal is the loss of electron. That metal is contain the Cl, bridge ligand తీసుకుంటుంది అది. Those metal is loss of electron. That metal is accept the bridge ligand. Those metal of gaining of electron, that is accept the aqua molecule. ఒక aqua molecule బయటికి పోయింది ఇందాక, ఇది రిలీజ్ అయిన aqua molecule ఇక్కడ in the oral reaction step 1, one of the aqua molecule release now, that is the attack or bind with the electron accepting metal. Okay, this is the inner sphere mechanism. So after transfer the reaction, what happens? The water molecule ఉంది, ఆ water molecule cobalt కి వచ్చేస్తుంది, Cl chromium కి వచ్చేస్తుంది. చూడండి final product. Okay, so in this reaction spontaneously మన aqua molecule, excess aqua molecule ఉంటే that is continue అయిపోతుంది reaction. All substitution అయ్యేంత వరకు జరుగుతుంది ఆ రియాక్షన్. ఒకవేళ మన రియాక్షన్ ఫార్వర్డ్ చేస్తే పాసిబిలిటీ ఇస్ దేర్. Okay, that means in this pentamine aqua complex is undergoes the hydrolysis. So how many ammonia ligands are there? That ammonia ligands all is the substituted ligands by aqua molecule in the formation of aqua complex. That is also possible. Okay, that is also possible. So this is for the inner sphere mechanism. Okay, so outer sphere also same thing. What is the difference? There is no bridged ligand. Okay, that is also, you observe that. Just 5 minutes. So in the outer sphere mechanism, there is no formation of the bridge ligand. So this is involve the 4 steps. One is the preparation of precursor complex. Okay, so oxidizing, reducing, both are connect. There is no bridge ligand. Rendu connect అయిపోయినాయి, bridge ligand లేదు. So electron means this complex is undergoes the excited state, అంటే యాక్టివేషన్ స్టేట్ లో వెళ్తుంది. సెకండ్ స్టెప్, దిస్ ఇస్ ఎక్స్ట్రా స్టెప్. ఇన్నర్ స్పియర్ కి అవుటర్ స్పియర్, దిస్ ఇస్ ఎక్స్ట్రా స్టెప్. దిస్ ఇస్ activation of precursor complex. That is after go to the excited state activation, the electron transfer takes place. Those complex is the loss of electron, that is indicate the plus. Those complex are gaining the electron, that is indicate the minus. Okay, after electron transfer takes place, separation of the two complex, both are individually separate. So those are the gaining the electron, that is a negative charge, that means decrease their oxidation number. Those are loss of electron or give the electron, increase their oxidation number, that is indicate what? Positive in the indicate increase the oxidation number, negative indicate decrease the oxidation number. So this is the electron transfer reaction. Okay, electron transfer reaction in outer sphere mechanism. So this is a mechanism. So this type of mechanism is 2 types of patterns are there. In the outer sphere mechanism. 2 types of electron transfer takes place. One is the self exchange reaction. Okay, the second one is the cross exchange reaction. Okay, electron transfer takes place from outer sphere mechanism. 4 steps are there. So that is the 2 types of complex are involved. That the pathway we can explain the 2 types. One is the self-exchange. Self-exchange reaction. Okay, self is nothing but same metal. Metal to metal electron transfer. Metal to metal. Metal complex to metal complex electron transfer is take place. That is the self-exchange reaction. Cross-exchange is nothing but metal to metal prime. Different metals are involved. Electron transfer from metal to metal prime or metal prime to metal. That is the cross. Cross. This is the self-exchange reaction. Mechanism is same. Okay, both the mechanism is same. So this is nothing about the electron transfer reaction from the so please go to the mute. So now stop the class. You can join another class is there 8 to 9:30. Okay, so almost this chapter is over. Some remaining other topics are there. So we'll explain the next class other topics. Okay.
Next class, which chapter?
Next class is the organic class is there.
Chapter, which chapter?
What chapter?
Yes, sir.
This is the black 3 reaction mechanism. Inorganic black 3 reaction mechanism of the transition metal complex.
Yes. So next class, which chapter are you?
So I don't know that.
Okay, sir.
Okay. So I will send the material in the Telegram group or in WhatsApp group. Already I will
Send it in Telegram group, sir.
Okay, okay.
Okay, thank you, sir.
You can join the next class, 8 o'clock. Thank you.
Excuse sir, please sir, ओडिया के अच्छे ग्रुप करंतु कांटेक्ट करंतु शेयर करंतु नंबर
ମୁଁ already କରିଥିଲି group रा
ସେଟା ଜାଣି होनी ना केमती आज्ञा नंबर टा केमती
group is there. That is
ओडिया वाला
I will check that. I will